So far, we have been calculating average rate of change over a specific interval, but what if we wanted to calculate the rate of change at a very specific instance? Let's look at example 3. Suppose a ball is thrown straight upward so that its height f of x in feet is given by the equation f of x equals 96 plus 64x minus 16 squared, where x is time in seconds. Part A says find the average velocity from x equals 1 to x equals 1 plus h. So if we do that, the average velocity is equal to f of 1 plus h minus f of 1 over 1 plus h minus 1. So let's calculate f of 1 plus h. That's equal to 96 plus 64 times 1 plus h minus 16 times 1 plus h squared. So we have 96 plus, if I distribute that 64, we get 64 plus 64h minus 16 times, and then I want to multiply 1 plus h times 1 plus h. That will give us 1 plus 2h plus h squared. So I get 96 plus 64. I should probably combine those. Let's see, so that would give me 160 plus 64h minus 16 minus 32h minus 16h squared. And then 160 minus 16 is 144, and 64h minus 32h gives us 32h, and then minus 16h squared. Now we want to evaluate f of 1, so f of 1 is equal to 96 plus 64 times 1 minus 16 times 1 squared, and if you simplify that, that will give you 144. So let's go ahead and come back up here and simplify this thing. F of 1 plus h we found was 144 plus 32h minus 16h squared, and then f of 1 was 144. And then notice that this 1 and this minus 1 will result in 0, so our new denominator is just going to be h. And let me make sure that I'm separating this part off. Okay, so now if I simplify the numerator, this 144 minus this 144 will result in 32h minus 16h squared over h. And in the numerator, we can factor out an h. And if we do that, we get 32 minus 16h like that, divided by h. And then this h and this h will divide out. And we did all this work to come up with the average velocity being 32 minus 16h. And so that is the average velocity when you are looking at the interval from 1 to 1 plus h. So we don't know what h is. They didn't give us a specific h value. But for example, if we wanted to look from x equals 1 to x equals 2, then that would make the h value 1, and you would plug in 1 for this h here. And from 1 to 2, the average velocity would be 32 minus 16 times 1, which is 32 minus 16, which is 16. So the average velocity between 1 and 2 seconds would be 16 feet per second, but they just wanted a general formula for the interval 1 to 1 plus h. Part B says find the instantaneous velocity at x equals 1. So basically what we did in part A was we found the average velocity from x equals 1 to x equals 1 plus h. And if we want, that was in order to find the average velocity, but we want to find the velocity exactly at x equals 1. And so the way that we are going to do that is we're going to consider this h value, and we want to make it very, very small. In fact, we want to have it go to 0 or approach 0 so that we're basically looking between x equals 1 and x equals 1 plus some very, 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 very small number. And the way that we think about that is by using a limit. Basically, we want the limit to go to 0, the limit as h approaches 0. So how are we going to write that? Well, we found that the average velocity was equal to 32 minus 16h. And so the instantaneous velocity, it turns out, which is just written as just v, is equal to the limit as h goes to 0 of the average velocity, which is the same thing as the limit as h goes to 0 of f of 1 plus h minus f of 1 over 1 plus h minus 1 in this scenario. And so that just allows us to calculate the limit as h approaches 0 of 32 minus 16h. Now, 32 minus 16h is a linear function, which is a type of polynomial. So that means that we can just plug in h equals 0. So that's going to be 32 minus 16 times 0. And if we simplify that, we get 32. And then our units are going to be feet per second. So that is the instantaneous velocity at x equals 1 second. So again, note that the average velocity is found over an interval of time. Instantaneous velocity is usually just called velocity, and it can be found at any specific time x as follows. Suppose that an object moving in a straight line has its position y at time x given by the function y equals f of x. Then the velocity function for the object at time x is given by v equals the limit as h approaches 0 of f of x plus h minus f of x all over h, provided that this limit exists. The instantaneous rate of change of any function can be found in the same way we find velocity. The function that gives the instantaneous rate of change of a function f is called the derivative of f. And derivatives are very important. They're a very major component of the study of calculus.